In this video, we will cover two topics, React and ECMAScript. The agenda for the video is as follows. We will start off by talking about what React is and how it relates to JavaScript. We will then talk about why one would consider using React. We will then cover JSX and its relationship to React. We will then talk about ECMAScript and some of the concepts available in ECMAScript that are used in React. We will then talk about functional programming. And lastly, we will cover building your first application in React. So what is React? Well, React is a JavaScript library. Since the early days of the World Wide Web, we have always dealt with static web pages, where HTML content was static on the web page, and dynamism was introduced to these web pages through the use of scripting languages like PHP, Perl, and in combination with HTML made the web page or the web environment more dynamic. JavaScript was introduced in the mix as well to increase the dynamism of these kinds of web pages. To make the web development process easier, a variety of libraries and frameworks were introduced. And some of these libraries included libraries like jQuery, Dojo, Bootstrap for CSS. Some JavaScript frameworks that were introduced were Angular, Move, Prototype. And what this meant was that for any website to properly function on a client's browser, the HTML content needed to be downloaded on the client's browser, but also the JavaScript files that enabled the dynamism of the web page also needed to be downloaded. While libraries and frameworks made websites and web environments seamless and made these environments rich and user-friendly and made it seem like these were single-page applications, there were certain consequences to the use of these libraries and frameworks to create these rich, dynamic web environments. The consequences were that the code base for these websites grew bloated over time because they needed to accommodate a variety of different browsers, a variety of different device types, so on and so forth. And so the code got bloated, and subsequently the amount of time it actually took to download the JavaScript files and the HTML files on devices grew longer and longer. In this environment, React was introduced. React is another library that is used to build single-page applications or applications that seem seamless and functional on a single page. The purpose of React is to generate your HTML on the server side rather than on the client side. The way legacy systems worked was that you have HTML and JavaScript that was downloaded at the client and was then rendered. React works with server-side rendering, where JavaScript is used to generate HTML output at the server, and that HTML output is then fed to the client. You can think of React as the view of the model view controller framework. It is used to generate the views that a user might interact with. And so React allows us to build single-page applications and render these single-page applications or build these single-page applications on the side of the server and then feed straight up the HTML to the client. For this purpose, React relies on this concept of components. Components can be considered to be the classes that one might be familiar with in the Java environment. A component is like a Java class in some loose way. Some of the cons associated with React are that if you have a heavy application, if you have an application that has a lot of components to it, well, these heavy applications degrade the performance of the React application. React also increases the complexity of an application through the use of components. JSX introduces the XML syntax to JavaScript. Traditionally, in web development, markup and logic have been kept separate. HTML files were separated from JavaScript files or JS files or JS scripts. In React, both these technologies are combined, and markup and logic are actually present in the same file. And so, in React, the rendering logic is actually part of the UI logic, and so there is no separation between the markup and the logic that is associated with that markup. JSX allows us to weave JavaScript into the HTML that we actually want to render seamlessly. JSX is a JavaScript preprocessor, or it's an extension to JavaScript, and allows us to render header tags, divs, spans, links, and other elements of a HTML web page while introducing JavaScript in the presentation of these elements. It allows us, in a way, to convert JavaScript to actual HTML. While one can actually write React code without the use of JSX, the use of JSX makes React more elegant and simplifies the building of single-page applications. React relies a lot on some of the new concepts that are present in ECMAScript. ECMAScript can be considered to be the parent language of which JavaScript is a child, or JavaScript is a variant. ECMAScript introduced several new concepts. Some of these have to do with variable declaration, where we can use const or const to declare constants and functions. ECMAScript also allows us to use let to limit variable scope to specific blocks, and allows us to also create template type strings, and this is an important part that React relies on, allowing us to echo out variable values as part of HTML rendering. ECMAScript also introduced the concept of arrow functions, allowing us to eliminate the use of function keywords, and also expands significantly on how classes and objects are used in JavaScript. Associated with ECMAScript and React is the concept of functional programming. Functional programming essentially treats functions like data. Functions are treated as variables, and information can be passed to and from functions, and in fact, functions can be passed to and from other functions. Functional programming is associated with the declarative programming paradigm. Declarative programming can be contrasted with the imperative approach to programming, where we use statements like fors and whiles and if statements, where we are telling the application how to do something. Declarative programming, on the other hand, relies on functions that already exist, and subsequently, declarative programming uses those functions to tell the application what to do instead of how to do it. It relies on the complexity inside the function to accomplish that activity. Declarative programming is a better way to represent data flow through an application rather than imperative programming. The link right there takes you to an article that tells us a little bit more about functional programming. Functions within the functional programming paradigm don't modify global variables or change the application state in any way. Within the functional programming paradigm, a variety of different functions can be put together to create these things known as compositions.